Okay, for those of you who haven't been with us, the first session we covered data structure and how the structure of your data sometimes isn't what you need it to be, and how it has to be restructured or reconnected to solve the problem that you're trying to solve. The second session covered the order of operations, and how the order of operations is what the process that Tableau goes through each time it creates a worksheet, and how that will affect your calculations, change the results, and maybe you don't get the answer that you wanted to because you're trying to do things out of order. Last week and this week, we're covering calculations and the language of Tableau. And next week, for the last session, we're going to cover filters, sets, and parameters. And those are the things that your users use to interact with your worksheet. Now, calculations, there's really only 4 basic types of calculations, and we covered 2 of them last week. We covered simple calculations and date functions. This week, we're covering the other 2, LOD expressions and table calculations, and quite honestly, they might have deserved each a session on their own. They're such a broad topic. Now, any of you who know me, who've seen me out on the forum, know that I just love using LOD expressions. I overuse them, and I admit to that without reservation. And the reason I like using them is because they allow you to create layers in your data set that aren't really there. Now, those layers never go back to your data source. They're in the data table for your workbook. But when you enter data into Tableau, that lowest level of data that you enter in is known as the grain of the data. And if you think of that data being a pyramid, if you sum all that data along any measure up to the very top of that pyramid, you'll end up with a single number. Well, what LOD expressions allow you to do is to come into that data set and decide where you want additional layers. And you can create an aggregation at those levels as you go up the pyramid, but the LOD expression itself is not an aggregate. And because of that, you can use it in any calculation, in any other type of calculations. Let's take a look at the language, if you will, or the language of LODs. LODs always have these curly brackets at the end, and then there's one of 3 code words. Fixed is used 80% of the time. Like we talked last week, there's include and exclude. Those are followed by any number of dimensions, a colon, and then some expression aggregate, because you're going up the pyramid. What do you want that level to represent? Like here, sum of sales. Now, the way you'd read this in words is you say, take all the combinations of these dimensions. Like region has 4 values, segment has 3 values, so take the combination of those are 12 values, and then sum the sales at that level. And create that layer in the data set so I can come back and use it later. Now, if you remember last week, we looked at a toy store example that I had where there were a couple of products, and those products came in colors, and it looked like this, and we opened up the data table underneath this data set, and we looked at something that looked like this, and we could see what each one of the records looked like. Now, I've come back in that data set, and I've added a couple LOD expressions, and I did this so that you can see what I mean by putting layers in your data. This is just a very simple LOD expression, and all it does is it comes in and it says, hey, at the product level, here's the product level, sum the quantity. So for product 1 here, that value is 39. For product 2, it's 24. And it's doing, it's just fixing those values at that level. I also did another one here where we take a look at the product customer level. So we got 2 different LODs here, and this one just says take the combinations of customer and product, and there's several products and 2 customers. Take those combinations and sum the quantity at that level. So here it's 25, and here it's 14, and so on. If we go back and we take a look at that data table, you can see now in these measured values, here's that first LOD that we put in place. Here's the second LOD. And if we look down at the detail data, those those measures are now in your data set. And that's what I mean about creating layers in your data. These are layers that are at a higher level than the original data that you included in the data set. You had this value, and now you've got these other values at different layers in your data set. Well, let's go on and see how we'd actually use this data. And the example that we typically start out with is this one, where this is nothing more than the this is just a table calculation, and I'm sure you've all used this table calculation before. I know it's Brandon's favorite. He already told me. It's the percent of total, and this is what the calculation looks like. This total is a table calculation, and this is what the value looks like. You can also write this as an LOD expression, and it will do the same thing. This just takes the sum of quantity here and divides it by the fixed sum of quantity, or the total quantity, and that's 152. And the reason you would do something like this, I can come in here and I can filter out some of the product. And we'll get questions all the time. They say, hey, I've got this calculation, I've determined the breakdown, the percent of total, but then when I filter, it keeps coming back 100%. That's not what I wanted. I wanted that percent of total to remain constant. And that's why you would use the LOD expression, so that this value, the fixed sum, is going to remain constant. Except, and you remember what we went through when we went through the order of operation, we talked about when you apply the filter, and we're filtering product here, when you apply the filter in relationship to the LOD calculation. Filters placed in context are applied before the LOD is calculated. Filters applied not in context, they're applied as dimensional filters in step 5 of the order of operation, are applied after the LOD is calculated. So right now, this filter is a dimension filter. It's not gray, so it's being applied after the LOD has been calculated. If we change that to add the filter to context, you'll see that it changes. The product is filtered out before the LOD is calculated, and it will change the results so that it always totals 100%. Let's take a look at some other things that we can do with LOD expressions. We talked a lot last week about averages and how averages are calculated. It's the sum of a value divided by the number of records to get the simple average that Tableau calculates. And we also looked at how you would go about doing a mathematical average. We took the sum of sales divided by the sum of quantities to get an average in that way. There's also something called the weighted average. And as an engineer, I'm very familiar with weighted averages. Some of you might be also. And what the weighted average does is it'll take and what we're going to do here is I've added price into that data set that we looked at before. And I want to find the weighted average price. And to get that, we would start by taking the price times the quantity to get the price including the weight, if you will. And you can see across here, 8 times 15 is 120, and so on. And we're doing that with an LOD. All we're doing is saying, look, I want to include customer, and we talked last week how the include statement allows you to set the level at which you stop breaking down the detail. And then to calculate the weighted average, we can come back and we can write a statement like this that says, take the sum of the value that we just calculated, and this is an LOD expression. It's not an aggregate in itself, so we have to sum it. So we take the sum of the LOD included weight and divide it by the sum of the quantity. And that's going to give us a weighted average. And you'll see as we compress our hierarchy here, the simple average here is 11.5. But the weighted average that knows that 25 of these were at $15 and 24 were at $8, The weighted average is $11.57. And I'm going to take this down one more level. Okay, we'll take it down one more level. And you can see the weighted average is $8.87. This is the type of thing that engineers and product managers do all the time. They want to know what the weighted average of my sales were. And that can be done very easily with LOD expressions. You try to do this with table calculations, it's much, much more complex. Another type of question comes up all the time. Users write in and they say, hey, look, I got to find the first value. I want to know what my initial sales were. And you can use an LOD expression for that also to find the first date. Here's this LOD expression. All this does is it says, hey, look, at each one of the subcategories, return the minimum date. That's the first time there was a sale by each subcategory. And when I bring that to the it looks like this. See, the first sale occurred on different dates. Now that you have that date, there's a lot of things you can do with it. You can find the first customer on that date. And in this example, we're going back to the subcategory level. And we just look and we say, well, look, if the order date equals that first order date, then tell me the customer name. But inside an LOD expression, the value has to be aggregated. And we've got a customer name. Our choices are, it's a text field. Our choices are min, max. We can't use ATTR. You can't use an attribute inside an LOD expression. But we have count and count D. Well, count and count D don't make any sense for what we're trying to do here. So I just took the minimum value as the aggregating factor. And that's going to return this value here. You can also go through and we can determine the sales on that first date or the value of that first order. And it's the same type of calculation. We're just going to compare for each customer name if the order date equals the first order date, then return the sales. And we have to aggregate that value again. And we're going to aggregate outside of the conditional expression. So we're going to sum that after we find it, and that's those values here. Now, some of you are probably way ahead of me and said, hey, wait a minute, there's an easier way to do this. And there is an easier way to do this. For something like this, we can use that LOD expression here as part of a true-false condition statement. And all we have to do is take a look at if the order date equals the minimum value or the fixed order date by category, then this is going to return a true. And if we apply that and just apply this as a true, we're going to show the filter here. These are the same values that we were looking at this other sheet, but very easy to find. And if we were to take a look at all the values, it would look like this. So we can find the minimum order date by subcategory, and then we can find all the data that goes along with that very easily using an LOD expression, where it wouldn't be so easy trying to do this another way. Now, at one point last week, we took a look at creating bins in values. We said, well, can you group together measures? And we said, well, yeah. We showed you how to do that with bins. Looks something like this. We open up a bin here. We create a bin. And we use something like this to create a bin. Well, I've got a data set here. Come on. You can't hear my machine whirring like crazy. Okay, I've got a very simple data set here, and this data set has for each user, it has a value between 20,000 and 30,000. And I can create an LOD that just looks at the user ID and then sums the value. Okay. Now, when I create that LOD, it returns as a measure, but because it's a fixed LOD, I can convert it from a measure to a dimension. And this is a very simple example, but this is something that I use quite often when I've calculated a number, but I don't want to treat it as a measure. I want to treat it as a dimension. And I can convert it to a dimension, and now this works just like our bin values. We've identified our bins, now using this LOD, and we can count the number of people in each group. Here, we're counting 1 through 7 for this group. You can sum the values. So we've essentially created bins, but we've done it with an LOD expression. Now there's one other example last week, we had from last week, where we took a look at doing year-over-year expressions. And I told you at that time, I said, okay, I'm going to show you how to do this, but I always advise users to use an LOD and not use a simple calculation. I've got a data set, and hopefully this is going to open up this time. I don't know why that is. My apologies. Okay. I've got an LOD, I've got a data set, and I want to calculate the year over year or period over period. And the first thing I have to do, the first thing you have to do when you're doing a year over year or a period over period calculation, you have to establish you have to anchor a date. You have to establish either a starting point or an end point. And I want to anchor this date to the last value in the data set. And this is a form of an LOD expression. You may or may not be familiar with it. This is sometimes called a table LOD. And it's just the squiggly brackets and the aggregation expression inside those brackets. And that is, and what I'm looking here at is the max date. And this type of expression, the table LOD, looks at the entire data table. It's not limited to looking at a dimension in the data table. It looks at the entire data table, and it returns the maximum date in the data table. And I'll use this quite often. I'll look for the minimum date or the maximum date in the data table. And the beauty of this is as you change the data, as you add more data, this will automatically update for you. You don't have to worry about it. And yes, you can do it with parameters, and we'll talk about that next week, but this is a way to always find the maximum date in your data table, or the min for that example. Then we're going to come back and we're going to take a look at our current year-to-date values. Okay. And if you were with us last week, this expression looks very familiar. The expression we looked at last week, we just took a look at, we said, well, we wanted the year of the order date to equal the same year as that maximum order date. So we take a look using date trunc. Date trunc will return the first day of the year. So if January 1st of the order date equals January 1st of the maximum date in the data set, and also if the day of the order date is less than or equal to the day of the maximum date, then record the sale. Now we're going to make that an LOD expression. Okay, we're going to encase that in parentheses, and we need to aggregate the expression to move it up that pyramid. So we're going to sum, and I want to calculate that at the category and the order date level. And that's going to return our sales by category for the current year. We can do the same sort of thing looking at the prior year, and this will look familiar if you were with us last week. This is the same expression again, except we've added this expression, this date add expression in here. And what date add will do is it's saying, oh, I want to go back, I'm going to decrement, I'm going to go back 1 year from the maximum date in the data set. So I want to look at last year, the same date, and make sure that we're in the same year and also the same date. It's the same type of expression. And then once we've done that, we can come back and we can take the difference between those two dates. And because they're LOD expressions, they are not aggregated. They are disaggregated data just at a higher level in your data set. So we take the sum of the current year minus the sum of the prior year, and we can do the same as a percentage. by taking, we've got the difference now. Now I aggregated the difference, and you can see right here, here's the data and it's aggregated. I can take the difference and divide it by the sum of the prior year to do the math to get the percentage. And you say, well, why would you go to all that trouble to do that if you didn't have to? Well, there's a couple of reasons you would do it, and we showed last week how you end up with a, and I'll show you later how you end up with a column that you really don't want if you use a table calculation. But I can take this data and I can plot it any way that we want it, or because they're LOD expressions, they're portable. You can use it in a summary table. You can move it from table to, from worksheet to worksheet. You can use those anywhere in your workbook because it's a layer within your data set. Okay. Now I know that was kind of quick. We wanted to go over LOD expressions and what LOD expressions are. Just remember a couple of things here. You're creating different layers in your data. You as the designer can decide where you want those layers and what dimensions you want, and you can determine how you want to aggregate that data up to that layer. And then you can use it anywhere in your workbook. You can use it in any expression. You can use it in table calculations. We're going to see how we did that in just a second here. I want to move on to table calculations. If you remember when we talked in session 2 about the order of operations, we said, well, table calculations are the last thing in the order of operations. It's step 10 of the order of operations. And we also said at that time, that's the one time I want you to think about that table looking like your Google Sheet or your Excel spreadsheet or whatever spreadsheet you're using. Think of it as rows and columns. Well, when we talk about table calculations, we talk about scope, and that's how much of the table, the formula that you're going to write applies to at any one time. We talk about direction. We're going to cross the table or we're going to go down the table. Okay. And we started with a very simple calculation. This is again the percent of total calculation, and that's the sum of sales. And I wanted to take a look at a couple of different types of calculations. I said, well, this is one that the percent of total we use all the time, but there's some other ones that are available out there. Now we can simply open up the sales and we can add a table calculation. We can look here, and we could just, whoops, that's not the, we're going to go back. We can add a table calculation. Okay. And we've got our choice of several to add from. We can take the running total. We're going to do that here in a minute. We can take the difference. That was the percent of total that we're looking at. I want to look at the year-to-date percent of growth. Okay. And this is predetermined for you, and we can look at that. And we get these values over here, and we can see what the values are, but let's take a look at how they're calculated. We can open this up and edit the table calculation. And you can see what's actually happened here and what Tableau has actually done for you. It's created 2 table calculations, and it's nested those calculations together. First, it creates a running total because we wanted the year-to-date comparison, okay? First, it's going to calculate the running total for you. And the aggregation is using a sum, and it tells you how it's done here, okay? And at the same time, it created a second calculation. And that second calculation is the percent of difference, and it tells you exactly how it was done. But there's another drop down here, and this one says, previous, and it says relative to. You can open that up and determine how you want that calculation made. This is a year-over-year calculation. We could relate that not to year-over-year, but this could be the percent difference on a running total basis relative to the last year as opposed to the previous year, or we could use the first year as opposed to the previous year. Now I've done that calculation over here. And he said confidently. Oh, I'm sorry, I've done it over here. We're gonna move over one back. I've done that calculation by hand also. You can do the same calculation yourself. First, I created the running total, and that's what we're seeing here. This is just, 14 plus 5 is 19, and so on and so on. That's just the running total. And then I can calculate the difference across the table. And this is the table calculation you would do for that. That's a lookup expression. And all we're saying here is look at the present value, the current value, minus the one that preceded it. And we're going to look across the table. Now notice the difference when I open up this calculation. And we've got the calculation assistant here, but we're only seeing one table, okay? The difference across, and it's showing us across the table. Now, if I open up the drop down, I can see the nested calculation. And many times you'll do this and you'll have several layers in here. And they're always, the innermost nest is at the bottom and you're working your way up that nest, okay? And if I look at the innermost nest, the running calculation is down the table, and you can change that if you wish. And the outer table calculation in the nest is across the table. You'll find as you get down into deeper and deeper calculations, sometimes you have to go in and change those. Okay. Now, I told you before that you can take LOD expressions and you can put them inside a table calculation. This example will look familiar to those who were with us 2 weeks ago when we looked at the order of operation. We had a request from users. They said, I want to rank by subcategories, by segment, by year, and I want to see how that varies over year. And we started by creating an LOD expression. Okay? And this LOD expression in words says, take all the segments, and there's 3 of those, and do the combinations of those and the subcategories, the 17 subcategories in the 4 years, and sum the sales at those levels. Well, there's 204 combinations, and you can see that right down here. So I got 204 different totals in my table. And then we came back and we ranked those totals. And we said, okay, rank unique. And we looked at, now, table calculations are always an aggregate because we're going from the detailed data up to the level of the visual that you see. We're going to sum the LOD expression that we just talked about, and we're going to do it descending. And we had a table that looked like this, and we were able to see, well, okay, phones were number 1 in these 2 categories. In 2017, they were 3rd in home office. We could see how that changed in 2020. Well, just this last week, somebody wrote into the form and they said, hey, look, I would like to be able, that's fine, but I can't see what I want to see. I'd like to be able to do this. I'd like to be able to highlight those categories. And this one had me thinking for a little while. I did it this way. There's a couple of different ways you can do it. But we've got that table calculation. We can use that table calculation that rank the LOD to our advantage. And in this case, I just used window minimum. I said, well, let's look at the minimum value of this table calculation. And if it's equal to the value that I'm looking at in the cell, then color that yellow, else color it blue. And I put that here on colors and, applied the colors. And, we got a table that looked really good. There's something else going on here. And I want to show you what it is. You can see that I put a blank in columns and I put a blank in rows. And we can hide those. We're going to hide those here just so you don't have to see them by just removing the show header and remove the show header there. So the table looks tight and you don't see those anymore. But the reason I did that was so that I could come over here, and that allows me to very easily fill that cell without overlapping the cell. Okay. Now I want to take a look at window sum and show you what this calculation window sum does. There's a and the reason I want to show you what window sum does, and let's see what that calculation looks like first. And we're going to look at this a couple of different ways in the next two charts. Window sum has an expression and also has a start date and an end date. Okay. Now what I've written here is just window sum, the sum of sales. It says look in the sales column and take the sum of those values. And I didn't put in a start or an end date, so it's going to take first to last. And when we open up the editor, I'm going to show you how the editor affects what's being done here. This calculation right now is at the category and the subcategory level, and it restarts every category. So the scope is a category, and we're summing down that entire category. So the scope and direction is the scope is the category, the direction is down. Okay, so we get 742 and so on and so forth. We could do table down. And when we do table down, the scope is the entire table, and we're going down. So this is the total for all sales for all years. Okay. We could do pane down. And when we do pane down, we're back at the same level that we saw before. We're at the scope being the pane, and we're calculating down the pane. Okay. What I've done here with special dimension is the same effectively as pane down or table down, changing those values. Okay, it's another way of defining the scope and the direction. Now, there's this thing called cell, and I want to show you what cell does, and we're going to show you on a different chart here. I've got a bar chart that looks like this, and maybe you've had this experience yourself. Just made a bar chart, and this calculation is the percent of total calculation. This is Brandon's favorite calculation. We're just doing a percent of total, and it's a table calculation. We've had users come back and they say, well, that's fine. That's a percent of total. I can see this total is 100%. But what I really want to see, I want to see the bar, and I want to see the different colors for the bar as a percent of the total length of the bar. Well, we can change this calculation to cell. And when we look, when you change it to cell and we look across the table, the cell here is the product. And now you're getting the percent of total for each individual product by using the scope being cell and across the table. I've got a couple more examples to show you, and then we'll take a couple questions here. When we were looking at table calculations, we said there were 5 functions that you could use to navigate the table. You know, we looked at first and last and index, and then there was this one previous value. And previous value allows you to return the immediate preceding value. And that's this part of the calculation here. Now I've got a data set, and I hope it's going to let me open up the data set. For some reason, I wasn't able to open it before. No, it's not going to let me open up the data set. Okay, I've got a data set that looks like this, and there's some nulls in the data set. So I've got values 100, 200, 300, but I've got some nulls in the data set. And the user came back and he says, look, if you find a null, just use the previous value. I want to use the previous value wherever there's a null. So we created this calculation. We're going to take advantage of 2 things here. First, the previous value. Previous value 0 says, hey, if I'm in this cell and I want the previous value, go up 1 value and return that value. And I've used that in a different type of calculation. This is an if null calculation, and I'm sure some of you know that. If null has 2 values, there are 2 expressions in it. And the way you would read this in words, it actually says, go to the column that's value and the sum of values. And if that value is not null, if there's a real value there, return that value. If it is null, then return this clause, whatever that clause is. So here we're going to return the previous value. And that's going to get these values. So I got 100, 200, 200 again, 200 again, 300. So it's returning the previous value. It's doing what we asked it to do. Now we can come back and we can use the second feature that previous value does. And if you look over here, you'll see that previous value can be used to calculate running sums or running products, or the sum of running products, if you will. It's a very good calculation for doing some things that you would do in Excel by multiplying two columns together and adding them after you've multiplied them together. And the way this works is we just say, hey, take the previous value and add to it, or take the value that's in this field, which is now the previous value field that we calculated, and add to it the previous value in that field. I know that's a little confusing the way I said it, and that returns a running total. Now I want to return back to the window sum calculation and show you how window sum can do the same thing. Window sum, the previous value without a start and an end, is going to sum the entire column here, previous value, and it's going to total 5,200. But we can come back in this calculation and put in a start. And we talked about first and last before. This is going to start at the first value, this value right here in that calculation, and end at the current position of the end at the current row, he said confidently. Okay, and when we do that, it's going to sum starting at the first row, adds the second row and the third column. It's going to go with the first, the second, and the third, and so on. And it's going to create the running sum using a different way of going at it. Okay. We looked at using some show hide filters, and I want to show you a different way of doing it. And I know I'm running a little late here because we got started a little late. So I'm going to cut to the chase and show you how to do a lookup filter. And lookup filters are a way okay. We've got a running total calculation, and you may have heard about lookup filters, and if you want to use a lookup filter, the first thing you have to do is the first thing we had to do here is create a calculation to look up the actual order date. And this is look up the attribute of the order date for the previous cell. And we actually use that in our calculation. And then the lookup filter itself, the show hide filter on the lookup. And here is where it gets a little bit more complex. I wanted to look at just the values for this year. And that's what I wanted to show you here. This lookup filter goes, and this is the same calculation we've used before. If the date is the current date, if the year is the current year and the date is prior to this year, I want to show it. If not, I want to hide it. But we have to use it as a lookup. And to use it as a lookup, we say, well, look up that. If the lookup of the order date, this value here for the current value is this year, and the lookup for the order date is less than the current date, show it, else hide it. And we can specify the period of time that we wanted to look at. I've got two more examples that I'm not going to be able to show you in detail today. They will be in the workbook and they'll be loaded in the workbook. But what I wanted to show you, and this question comes up quite often, is how you can get the total of the top in and group all the others together and get a summation that will show you what the top, in this case, 5 values are and what the remaining values are. And this too is done with show hide filters and nested table calculations. What we're actually doing is we've created this column, and I'll show you the calculation for that real quick. And then we're going to hide the subcategory label by, and then we're going to go through this calculation. Which says, and I'm going to go on this sheet because you'll see it better here. What this calculation says is, look, I want this value and I want that value. This value is the last value. This is that last filter again. If last equals 0, if it's that value, or this label that I created, the top 5 and other label, if the value here and the value there are not the same, then show, else hide. And when we apply that filter, that's how we get to the total. This gets around the problem that you have with grand totals not being able to total aggregated values. The top 5 are simply calculated as a, if rank is less than 5, then it's top 5. If there's not top 5, it's other. And then this value for this value to determine. This gets a little complex, and you can download the workbook and you can see it there. But essentially, if the rank is less than 5, if it's one of these 5 values, then do the running total. If it's not one of those 5 values, take the window sum, which we just saw was the total value, minus this value, and you'll get the value that you see here. Okay. Next week's going to be the last week that we look at this. We're going to look at filters, sets, and parameters. Looking forward to being with you.